Hello, everyone. My name is Alina, and I will be going over question 8 of the CS88 midterm cycle edition. So let's take a look at what this function wants us to do. Create a function cycle add that takes in a 2D list of integers, and the list of integers the list of integers can be of different lengths, and then return the result of summing up the values of each of the lists element-wise, cycling if necessary if the list is too short. So, for example, cycle add 1, 2, 3, 5, 7 will return that. Um, and yeah, notice how we cycled back to the first value of the first list to get 1. So I think, reading this, there's a lot of text and it could probably get confusing. So what I like to do when I am presented with a more involved coding question, I'll just take a look at the doc test and see if it matches up with what the example, what the instructions say or what the example is given. And so let's go ahead and analyze these doc tests. So we have, yep, right there. So we have cycle add 1, 2, 3, and 1. So we have a 1, 2, 3, and we have a 1. And so returns 2, 3, 4. So let's see how we can do this according to the instructions, according to the algorithm presented in the instructions. So we just add up the list element-wise and then cycle back in the short list, so returning to the beginning of the short list if we still have elements in the long list to add. And so what we have is, basically all the lists start out at the first element right here. So 1 and 1. 1 plus 1, does it equal 2? Yes, it does. And indeed, we are doing 1 plus 1 right here. And so we move on to the next element, 2 here. But this list only has that one element. And so we're going to cycle back to beginning, which is just itself again. So this is going to stay here. And so we do 2 plus 1, as stated here. And indeed, 2 plus 1 is 3. So then we now move on to the last element of the long list, 3. And once again, we're going to have to cycle back on this first list, but in actuality, it's just staying itself because there's only one element. So 3 plus 1, 3 plus 1, and that equals 4. So we can see that, through walking through the doc test before you start writing any code, you can kind of test your understanding of the question and then also check for any special edge cases that you might need to take care of. So in this case, for example, a special case would be the second list is just one element long. So we can go on to the next doc test. Let me see if I can, actually, I'll just keep writing them. So next doc test, we have 1, 2. So 1, 2, and we have 3, 5, 7. 3, 5, 7. All right, so just like our last one, both lists start out at their first elements. So 1 and 3, 1 plus 3, 1 plus 3, that equals 4. We're good, so we're so far so good. We move on to the next element. So each time the index of the list changes because we're adding these element-wise. So the first list will also move on to the next element. Second list will also move on to the next element. So now we're doing 2 plus 5. So 2 plus 5, and that equals 7. Cool, makes sense. Let's move on to the next. So this first, well, we can know that this second list will indeed move on to the next element because it still has a next element to move on to. But this first list, it's run out of elements. So it's going to have to cycle back, which is why we're going back to 1 here. And then we're doing 1 plus 7, which is shown here, 1 plus 7, and that equals 8. So we can see that the long list is always increasing its the index of its elements. So we're always going from left to right on the long list, while the shorter list is going to have to cycle back at one point to accommodate whatever extra values that long list has. Cool. Let's do one more example in the doc test just to make sure we've got this down pat. So this time we have 4, 2, 0, and then a 1, 2, and 2. So this is interesting because we actually have 3 lists now, but that doesn't really matter because we're just adding up the elements. No matter how many lists there are, we're just adding them all up element-wise. So we do the same procedure. We start out with the first element in each list. So 4 plus 1 plus 2, which is shown here, and that is equal to 7. Cool. We move on to the next element. So this first list moves on to its next element. This second list moves on to its second element. And this third list, well, like our first example, it only has that one element. So it's going to stay where it is, right there. So we do 2 plus 2 plus 2, and that equals 6. Cool. Now, last one. This first list once again moves on to its next or last element. The second list, well, it was already 2 in the last round or in the last iteration. So now it's run out of elements, so we're going to have to cycle back to 1. And once again, this last one, this third list, it's going to stay where it is. So we're doing 0 plus 1 plus 2 now, and that equals 2, 3. Cool. So now we have a pretty good understanding of how our list works, and we can begin to start thinking about how we can fill in the blanks for this question. So before filling in, before trying to solve any programming question, I would recommend going through the algorithm or like the instructions given and trying to see how you yourself would solve the list first, and then try to see if that can be applied to the method that is given to you in the starter code. So what would we do in order to accomplish this cycle add? Well, first we have to, as we've seen here, we're going to have for loops of some sort because we're continuously looping through the elements of the list. And we also need a way to tell when we need to cycle back. So do we cycle, for example, well, 2 things actually. So when we need to cycle back and which list we need to cycle back on. So when we need to cycle back, that's when the shorter lists run out of elements. So when we don't have any more elements, we're going to have to go back and go back to the beginning. And then you'll see later that this involves just a little bit of tweaking on the index variable. And the second thing we have to determine is which list to loop back, or to cycle back, my bad. So, we can see, do we loop back, or I keep saying that, do we cycle back on the longer list? I mean, do we ever, end up here and then go back to 1? No, because the long list is, the long list represents how many elements we will, or how many times we will add the elements, and also the length of our return list. You can see here that the longest list here is 3 elements long, and it's 3 elements long return value. Longest list is 3 elements long, return value 3 elements long. Longest is 3 elements long, return value 3 elements long. So we only go until we reach the end of the longest list. So basically you have to figure out what list is the longest list, and then create the for loops and the cycles for the other shorter lists accordingly. So now that we kind of have that procedure in mind, we can go ahead and take a look at what the code that is presented here. So actually, I don't know why I changed color. Let's go back to blue. So we can see here that we have a new list initialized to an empty list, and we also return new list. So since the return value is the result of all these additions, we know that new list is going to be the return value, where we're going to be holding all of the results of the additions that we're going to do. So we're going to have to be, keeping on appending stuff to this new list as we go along. And then next we have longest. We don't know what that is, but we can kind of, using the variable name as some assistance, we know that we will have to figure out which of one of the lists is the longest list first before we do any addition. And so longest here is probably figuring out, where the longest list is, what the longest list length is, something along those lines. And we see here there's a for loop, so that's probably, looping through the elements to add. We have a value here that's 0. We don't know what that is yet. Let's just keep looking. We have another for loop. Okay, so this is probably the for loop that is going to be going to the shorter list, because we know that the longest list for loop, it's just going to be a simple left to right for loop. We're just going to iterate through its elements one time and be done. The shorter lists, they might have some, they might have more processing to do. So maybe that for loop is going to be processing with the shorter list. But also, like when I first looked at that problem, that was definitely my first impression. But also, if you kind of take a look at the function description, we do have a case where we're not going to have just one shorter list, we're going to have multiple shorter lists. And there's no limit on how many shorter lists we have. And so we can have like, instead of having 2 here, we can have 3, 4, 5, 10, a million. So we don't really know how many shorter lists we have. So in actuality, this for loop is probably going to be, looping through all of the other lists in the that was passed into cycle add. And so, always having, it's kind of hard to balance, like what your first impression is of a function and what is actually necessary in the function description. So going through it, kind of methodically like this before you write anything is a good way to make sure that your intuition kind of lines up with the instructions. And so in here we have some indexing magic that's happening. And you can assume that this is where we're going to be doing the looping back because of the module. And we add value to value. So this is probably the ending sum that we want to add to new list. And then this last line, we're probably adding that value to new list. Alrighty, cool. So now we have that, we can go ahead and actually write the function. So we have new list is empty, cool. Now we have longest. So we have to figure out basically which one of the lists is the longest. And we do that by measuring the lengths. So len list. And we do know that next in the for loop, we have to be able to iterate through all of the elements in this longest list. And so probably longest is going to have to return a number or a list of some sort, but numbers are generally easier since we are comparing lengths of the list, which is number. So longest is going to return a number that we can then use in our for loop at the bottom here. And so, we can go ahead and start testing out things for longest. I'm gonna make this longer so we can write more. So we know that we're going to have to compare the lengths of the list, but we only have one line to do it. We can't really make a for loop and kind of compare each list length at a time. So we're going to have to use a list comprehension. And so what that looks like is, 2 brackets for the list and the comprehension. So what do we need from each of the lists in order to compare them to each other? We need the lengths. And so we can do len list or list in list. So that was a lot of code. Just to break it down, we have list here, which is passed in, and then we use list as the variable for each list in list, and we're just taking the length of it each time. So now we have a list that represents all the lengths in the list, and we need to find the one with the maximum length. So we can use max. Cool. Let's make this a bit smaller and put it right here. So this indeed gives us the length of the longest list, which we can then use to iterate through in this for loop. So we can say, since we have we have that upper bound for a range, which is longest, we can just say for I in range longest. And then we make that longer, smaller, right here. For I in range longest, so it's just iterating through, each index. So for example, in this example, actually let me do use difficult. So in this example, longest here would be this list, and its length is 3. So we're just going to go for I in range 3, which is going to be 0, 1, and 2, like that. Cool. Just writing stuff here, just writing notes and numbers here, so we can use those to compare and as reference for the next part of our code writing. So now we're inside the for loop. We have value equals 0 because we haven't added anything yet. So we're just going to start out with 0. And then 4, now this one was, probably the trickier one, but 4 is going to be looping through all of the lists in lists. So okay, I already have text selected. So let's go ahead and do this. How do we loop through the lists and lists in order to add elements together? Well, we know that there is another type of for loop where we don't go by index, but rather just the elements. So we can just say for list in list, like that. So for every list inside the lists variable that was passed in. So for list in list, which will basically, go this list and then this list and then this list, or like this list and then this list, so etc. So for list in list, and inside that for loop, we're doing some indexing magic and then adding them up. So here is the, I guess the trickiest part. How do we make sure that we go back to the beginning or stay at our position when necessary? Let's take a look. Let's do green. So we have, let's say we're at this list, right? Because we're looping through all the lists. So we're going to be starting out with this list first in this third example. And so this list, since we're in I, we have this variable I. We're probably going to be using that because it is a list index source. It is the list index of the longest list. So we're going to be manipulating that list index I in some way in order to get the true index of the element that we want to add. And so I right now, we're starting out, I is going to be 0. So let me just do a green arrow to represent I. I is now 0. So these 0 elements. So for the longest list, we know that we just want to keep I as is. We want to add the 0th element. For this list, we also want to add the 0th element, and then this list as well. So maybe starting I at 0 was probably not the best example, but we know that I is going to increment by 1 since it is a for loop. So we're going to go to I is 1 here. So once again, in the longest list, we know that we want to keep I the same. I is going to have to be 1 here. In this next list, since we do have room, I is going to also be 1 in this list. But here, this only has a 0th element. It doesn't have a 1th or first element. And so we have to manipulate I, which is now 1 somehow, in order to get back to 0. So we know that they've given us this modulo len list. Maybe let's see if we just insert I into here, maybe that will do the trick. So let's see if we have, in this case, we have I, and then modulo the len of this list, which is 1. I modulo 1 is going to be 1 modulo 1, which is 0, because 1 divided by 1 is 1, there's no remainder, and so modulo 0. And is it true that we need index 0 of this list? Yes. And so we can say, okay, maybe just passing I in here will work. Let's confirm it with another example. So let's go on to I is equal to 2 in the longest list. So I being equal to 2 is, we're going to keep that I for the longer list, or longest list. And then for this list here, it no longer has a second element. So we're going to have to go back to the beginning, here. What is happening? Back to the beginning here for its 0th element. And so let's try it again. I is now 2, and the len of this list is also 2. So I'll just write 2 here. So we do I modulo len, so 2 modulo 2 is equal to 0 because there's no remainder. Cool, and we do need that 0th index. Let's try again for the third one. So I is 2, 2 here, we modulo 1. 2 modulo 1 is also 0, and it's true that we need to be able to go back to the 0th element here. So having tested that, we know that if we just put an I here and have it be evaluated against the modulo of the len of the list it's on, it's going to give us the correct index value. Oh, and I should probably just do this for, pedantic purposes, but if we were to have, let's say we're at this element here, so I is still 2, and the length of this list is 3. Let's do 2 modulo 3, and that gives us 2. And so we know that this works because indeed we want to keep index 2 here when we're looping through the longest list. Cool, so I works. So now it's just a matter of adding the list elements. So value plus equals whatever list we're on, and then index to get the element at that index. Cool. And lastly, we've determined this before, we're just going to have to append these values to the new list. And so we're going to have a new list dot append value. Let me make that longer and more pleasing to the eye. Yeah. So now that we've append value to new list, we're going to append 4 plus 1 plus 2 to new list and have it 7 if we're using this example. And then 2 plus 2 plus 2, which is 6. 0 plus 1 plus 2, which is 3. And after we've done all the additions and all the looping, we'll return new list and we're going to return 763. And that is the correct return value. So this is it, the solution for question 8.